Let me ask you something. Have you ever stared at a page full of numbers and formulas, read the same line over and over again, and still felt like nothing was going in? Have you ever spent hours studying maths or physics, only to forget most of it the next day? Yeah, you're not alone. In fact, this is exactly how most students are taught to study, the wrong way. They're told to work harder, practice more, or just memorize it. But let me tell you something that may sound harsh at first. Hard work alone doesn't guarantee success. Think about it. If hard work alone was enough, wouldn't every student pulling all-nighters be acing their exams? But they're not, because hard work without direction is like rowing a boat with no compass. You can row all day, but you'll never reach the shore. The real secret, the thing that separates top performers from everyone else, is not that they work harder. It's that they work smarter. And today, I'm going to show you how to do exactly that for maths and physics, arguably the two most feared subjects of all. But before we dive into strategies, let's clear up the biggest myth that's been fed to you for years. The idea that you're bad at maths or not a science person. Let me be blunt here, that's a lie. A lie repeated so often you started to believe it. Maybe it came from a teacher who rushed the syllabus, or classmates who made you feel slow, or maybe even your own family. Oh, we're just not math people in this house. But none of that is real. Because the truth is, your brain is designed to learn complex ideas. It just hasn't been trained the right way yet. You've been taught what to study, but not how to study. No one handed you a manual on how to remember formulas effortlessly, how to solve physics numericals in minutes, how to make concepts stick in your long-term memory. But that ends today. Because by the end of this video, you'll have a system, a practical brain-based method that will allow you to understand difficult topics faster, retain information for weeks, even months, and cut your study time in half without sacrificing results. Sounds like a bold claim, right? Good, because it is. But it's also completely real when you stop following outdated methods and start using what actually works based on how your brain is wired to learn. Now let me give you a quick reality check. This video is not about shortcuts or hacks that work for a day and then fail you in the exam hall. This is about building a smarter, more efficient study system that trains your brain like an athlete trains their body. You're not going to cram randomly anymore. You're going to learn how to code information into your brain, like a programmer codes software. You're going to stop studying like everyone else and start learning like the top 1%.
And here's the best part. You don't need to be a genius. You don't need to be gifted. You don't need 10 hours a day. You just need to be willing to change the way you approach your studies and trust a better system. So, if you're tired of wasting time, if you're ready to finally understand physics formulas instead of memorizing them blindly, if you want to stop fearing math problems and start solving them with confidence, then stay with me, because what I'm about to share with you will change the way you study forever. Welcome to the smarter way to learn maths and physics. Let's begin. Step 1. Cognitive looping, mental stacking. You don't learn linearly, you learn in loops. This step reprograms your brain to retain complex concepts by exposing it to rotational contact with related ideas. How it works. Instead of finishing one topic completely, you stack 3-4 interconnected concepts in a loop. For example, 1. Projectile motion. 2. Newton's second law. 3. Friction. 4. Momentum conservation. Now rotate through these quickly. Not solving yet, but touching each idea lightly. 3 minutes skim notes. 2 minutes close eyes and recall. 1 minute explain aloud to imaginary student. Then repeat the loop twice. Each time your understanding compounds. Why this works? The brain loves patterns and links, not blocks. This looped exposure creates a mental map, a web of ideas your brain will remember, even under pressure. This is not multitasking. This is neurostacking. It's how polymaths like Leonardo da Vinci thought, by jumping between systems and letting insights emerge from overlap. Step 2. Structural dissection of problems. Don't solve problems. Decode them. Before solving, dissect a batch of 10 questions from different chapters. Your goal is not to get the answer. Your goal is to train your brain to recognize the skeleton of the problem. Ask, what concept does this question activate? What kind of thinking path does it demand? What makes it different from other problems? This builds problem intuition, where you begin to see the solution before writing anything down, like a chess master knows the move before analyzing. Do this 3 times a week, 15 minutes per session. This alone will cut your question-solving time in half by exam season. Step 3. Neural context imprinting. Your brain doesn't remember facts, it remembers situations. This step teaches you to tie every concept or formula to a mental scenario. Let's say you're learning. Instead of memorizing that, imagine a kid trying to push a heavy cart. The harder he pushes, F. The faster it moves, A. But if the cart is heavy, big M, it moves slower. Now your brain stores the concept as a story, not a symbol. Pro trick. Every formula you learn, immediately ask, where would I see this in real life? What's the drama happening here? These mental anchors make recall automatic because they link logic to emotion and motion, the brain's 2 favorite things. Step 4. The cold mind protocol. Memory under pressure. Only cold recall reveals what's truly been internalized. Once a week, choose a set of problems from topics you studied a few days ago. Now, attempt them first thing in the morning. No warm-up, no revision, just raw brain versus real problems. Why? Because your cold state mirrors exam conditions. It reveals which concepts are deep-rooted, which ones are fake confidence, what your instinctive recall is. Bonus. After the cold session, immediately review just your errors. This creates emotional spike learning, which burns mistakes into memory forever. Step 5. Interference patterning. Reverse integration. Instead of learning topics forward, learn them backward. After you complete a topic, go to an advanced mixed problem set, not the simple ones. Try to identify which chapter the problem belongs to, what concept it's testing, why it's structured that way. This is called reverse learning. It forces your brain to reconstruct knowledge like a detective. It doesn't just know the formula, it can recognize when to use it, how to adapt it, and why it applies. This method builds flexible mastery, not rigid memory. Step 6. Anti-focus drift technique. Rest is not for recovery, it's for processing. Here's the twist. The most powerful learning happens not during study, but during what looks like doing nothing. Here's what you do. Study a dense topic intensely for 25 to 30 minutes, then immediately shift to an unrelated mental activity: sketching, listening to music, going for a walk, solving a riddle. During this break, your mind enters the default mode network, a neural state proven to form long-term connections subconsciously. It's like mental fermentation. The information sinks in deeper without you even realizing it. Step 7. Predictive brain simulation. Pre-recall training. Study as if you're the examiner. Before reading a new concept, pause and ask, if I were writing the exam, how would I ask a question about this? Then guess. What formula might be involved? What trap could I design in the options? What would make students get it wrong? This builds a predictive learning mode where your brain is trained not just to know, but to anticipate. Why it works. When your brain makes predictions and then sees the answer, it experiences a mini dopamine reward, reinforcing learning automatically. Step 8. Fractal scheduling, non-linear revision timelines. Linear revision kills memory. Fractal review builds mastery. Instead of revising topics at fixed intervals, like once a week, use a fractal pattern. Example, Topic A. Review after 1 day, 3 days, 7 days, then 1 minute quick glance every 10 days. Topic B. Review after 2 hours, then after 2 days. Then do a 1-question cold recall. Why? Because memory isn't built by timing. It's built by surprise reactivation. Fractal review triggers your brain's prediction error and forces it to pay attention again. Step 9. Concept compression via mental telepathy. Speak your thoughts like you're sending them telepathically. Here's a strange but elite method. Choose a complex concept. Now try to explain it mentally in 10 seconds with 0 notes, no equations, just essence. This is called concept compression. Why it works? It forces you to distill complex ideas, spot what's unnecessary, strengthen your mental representation. When you can do this, it means you've internalized the concept at the core neural level. This is how Nobel scientists and top researchers test their own understanding. Step 10. Construct a mental physics lab, imagination environment. Everything in physics and math can be experienced in your mind. Final step. Start building a mental lab, a place you visit in your imagination where you experiment with concepts. Picture this. You're inside your mind's physics chamber. You imagine dropping a ball in 0 gravity. You mentally observe vectors changing. You simulate equations as events, not numbers. This technique is known in elite neuroscience circles as embedded simulation learning. It's how prodigies visualize abstract concepts effortlessly. You're no longer a student. You're a creator, inside the system of knowledge itself. If this rewired your brain even a little, if even one technique made you pause and think, then imagine what happens when you actually use them. This isn't just about studying, it's about building a brain that doesn't forget. Now tell me in the comments, which step hit you the hardest? Which one are you starting tonight? I read every comment. Let's turn this into a lab of minds sharper than the system ever expected.